know, or do you have any relationship with meteorologist James Spann in Birmingham, Alabama?
The answer is no, and yes, I've been asked that many times.
This week, a special edition of the Carolina Weather Group. Countdown to launch. The Carolinas and the entire Atlantic coast about to get a brand new weather satellite. We talk with Goes U program scientist Dr. Dan Lindsay about weather detection aboard the new satellite, and then Dr. Jim Spann, a senior scientist with NOAA's Space Weather Observation Office, talks about new space weather detection tools just on this brand new GOES satellite. All this as NOAA, NASA, and SpaceX prepare for liftoff. The first launch window, Tuesday, June the 25th at 5:16 p.m. Eastern Time from Kennedy Space Center in Florida. I'm James Brierton in Charlotte, and welcome to the Carolina Weather Group. Let's welcome in our first guest, Dr. Dan Lee. Dan, thank you so much for making time to talk with us here on the Carolina Weather Group again. You are the GOES-R program scientist. You are the man to talk to when we want to know all things about these GOES weather satellites. So let's start at the very basics. What are they, and what is it that is about to rocket into space next week? What should our audience be excited for?
Yeah, so first of all, thank you so much for having me. So the GOES-U satellite is, of course, an acronym, GOES, as everything in the government is an acronym, it seems like, stands for Geostationary Operational Environmental Satellite. And then the letter U at the end represents sort of a sequence of letters, and that's how we identify the satellites before they're launched. The first in the series was GOES-R. It launched back in 2016 and then became GOES-16 after it reached geostationary orbit. And since then, we've had GOES-S, GOES-T. They launched in 2018 and 2022. And then next week will be GOES-U. And this will be the fourth and the final satellite in the GOES-R series before we move on to the future program called GeoXO.
I want to talk a little bit more about what this series does in just a moment, but let me dive into a point that I think you just brushed upon, which is that this will get renamed, if you will, when it gets into space and gets into operation. A couple months down the line when people are looking at weather satellites, what identity will this satellite have?
The three that are in orbit now are GOES-16, GOES-17, and GOES-18. And as you might imagine, once this one reaches geostationary orbit, it will be renamed from GOES-U to GOES-19. And at that time, it will begin going through its checkout phase. That means we test the calibration of all the instruments. There's really a lot of testing that has to be done, largely on the engineering side, but also on the science side to make sure the data looks good. And then if everything looks good, the plan is for it to transition to the GOES East satellite. It's going to replace the aging GOES-16 satellite sometime next year. That's the current plan, at least.
Well, that is selfishly good news for us here in the Carolinas, because this will become our new weather satellite then.
Exactly, yeah. So GOES East, of course, is we call it the sentinel in the sky, and for the people on the East Coast, it certainly is important. Keeping an eye on the Atlantic Ocean for those potential hurricanes, as well as, of course, severe storms and any other sort of hazard you can think of in the entire hemisphere.
Well, you mentioned that this is the last in a series, and it's going to become our new eyes over the East Coast out into the Atlantic. So are there any new tools that this satellite will bring versus the one that it will be replacing?
So the satellite largely has the same complement of instruments. And I can go through those in detail, but just really quick. The two main Earth-pointing instruments that are helping the weather forecasters today are the Advanced Baseline Imager, or the ABI, and the Geostationary Lightning Mapper, or the GLM. The imager is the instrument that gives us sort of the regular imagery that you see on a daily basis. When there's a hurricane, it's the thing you can see that shows the hurricane spinning and it approaching the coast. And the Lightning Mapper allows us to track lightning activity really across the entire globe and gives the entire hemisphere, and gives us a constant view of that lightning. The other instruments on board are all focused on space weather, which is, of course, very important as well. Some of them point at the sun, and some of them measure harmful particles that are coming from the sun or from elsewhere in space approaching the outside of the Earth. The one new instrument that we do have this time that none of the other satellites have is something called the compact coronagraph, or SECOR. And this is one of those sun-pointing instruments. It joins SUVI, the solar ultraviolet imager, which also looks at the sun. And what the coronagraph does is, you may remember, many of you probably traveled out to catch the eclipse that happened and moved across the country back in April. During the eclipse, whenever the moon is in front of the sun, which of course is the definition of a solar eclipse, what it allows us to do is see the outer rim of the sun. That's called the corona. And that's one of the coolest parts of seeing the totality of an eclipse, is being able to see that area that you can't see otherwise because the sun is just too bright. And so the way the instrument works is it has a little piece that sort of blocks out the sun and makes its own eclipse, sort of, and allows
Wow.
us to measure the corona itself and measure things like coronal mass ejections coming from the sun, solar flares. And the forecasters use that information to say, when will that coronal mass ejection or those harmful particles reach the Earth? And maybe 1 to 3 days later, something like that. And that way we can, put out the necessary solar storm warnings.
We're going to be spending more time talking about space weather and how these satellites monitor that coming up in the second part of our episode this week. What's the lifespan of a satellite like this, Dan?
These satellites are designed to last 10 years. So GOES 16 launched in 2016. So it is coming up on its, pretty close to its 10-year lifespan. Of course, GOES 16 will become the on-orbit spare after it gets replaced by GOES 19. So it does still have some useful life left. And that's the reason it's our spare, is because it can still serve as a backup. Occasionally, they do last longer than that. They have fuel to make them last even longer, but it really just depends. And we often do put sort of the latest and the greatest in operations whenever we get it, especially when it's carrying a new instrument, like in this case, that compact coronagraph.
I'm curious to know, is there a functionality or tool on board where you go, man, I really wish somebody would ask me about X. I love talking about blank.
Well, we mentioned the lightning mapper earlier, and that's something that is really pretty cool. And the cool thing is we've learned to do some new things with lightning recently, with the aid of the tool which many people are probably familiar with, called machine learning. So an example is there's a new product that is in the midst of becoming operational, called Lightning Cast. And the way it works is it was trained on past data, and what it uses data from the advanced baseline imager as input and uses the GLM as truth. And so basically it says, if the clouds are doing this right now, what are the chances that there's going to be lightning 1 hour from now? And this is especially important for, say that somebody's going to a Carolina Panthers game,
Okay.
and there's a potential for a storm in sometime that day. Forecasters may watch approaching clouds, or they may watch bubbling cumulus clouds. And what this product will tell them is, what are the chances that at that point at the stadium, there's going to be a lightning flash within the next hour? Maybe it's 10%, maybe it's 90%, maybe it's somewhere in between. But that information can be really helpful for making decisions about, say, clearing the stands or asking the players to get off the field, that kind of thing.
What can you tell us a little bit about the next generation of weather satellites that will come following this successful launch?
So NOAA's been working on planning for the GeoXO program. Once again, we have an acronym here. GeoXO represents the geostationary extended observations. That's what the acronym means. And what that means is we are going to improve on the instruments that we have now. So, and we'll still have an imager and a lightning mapper, but we're going to make improvements on the imager, primarily on the resolution side. So, for example, the imager now, the current imager can see, I'll say, see a fire, hotspot for a fire, which is something we haven't mentioned in terms of applications, but that are relatively small. Say a small field burning, or if there's a really hot, if a barn caught on fire and it was a really hot fire, that's something we can spot now. But with the future imager, it's going to improve its resolution by a factor of 4 in area. And what that means is something that's about 1/4 that size will be detectable. And that's really going to help, I guess, mainly out west where, wildfires are a bigger deal, but certainly in the east, there are wildfires as well sometimes.
Yeah,
And
we've had our
that's something to
handful.
keep an eye on. I would say the most exciting part about GeoXO is we're going to add 3 new instruments that we don't have now. The first one is weather focused. It's called the Geostationary Hyperspectral Infrared Sounder. And that's a lot of words, but what that really means is with hyperspectral means we're detecting the atmosphere in lots of different wavelengths, something like a few thousand different wavelengths. And that tells us what's happening vertically in the atmosphere. So what are the temperature and the water vapor, not only say, over just the entire troposphere, but say at several different levels throughout that. And that information is something that the models really need as an initial condition. You feed that into the models, and the models improve and give you a better forecast for tomorrow or 5 days from now.
We don't have a weather balloon launching really remotely close to where I am here in Charlotte. And so to get that layered data, you got to go farther away, and to be able to use remote sensing for that is a really smart application.
Yeah, that's a great point about those gaps and where the weather balloons are launched.
When is the approximate arrival time of the next generation GeoXO?
Yeah, so the first GeoXO satellite is planned to be launched in 2032. And that sounds like a long time from now. I guess it's 8 years from now. Time flies. And what's good is that the satellite we're launching next week, goes U, which will become GOES 19, is going to take us well past 2032. And so I think that's probably its most important role, is sort of bridging the gap between the current series that we have now and the future series, that GeoXO series. And the operations for GeoXO are going to last out into the 2050s. So we're talking, past our retirement age and into our kids' ages, and maybe even to their retirement age, is going to be the future in terms of geostationary satellite observations.
In the last few minutes we have left, is there anything we haven't talked about, anything I haven't asked you about that you want to make sure people know about this GOES 19 satellite?
I highly recommend, if you have the chance next week, the launch time, the launch window begins at, I believe it's 5:17 p.m. Eastern time on Tuesday, the 25th. And you can find information about this throughout social media, anything with NOAA satellites. You can also check the NASA, I guess it's NASA TV is what it's called, to actually log on and be able to watch the launch. I highly recommend checking it out. And anybody that's anywhere along the east coast of Florida probably sees launches all the time. Just step outside and take a look at 5:15 or so next Tuesday, and because the launch will really be spectacular. And this, by the way, I forgot to mention one thing. We're launching with SpaceX for the first time on a SpaceX Falcon Heavy rocket. And what happens is 2 of those boosters from the SpaceX are going to be landed back down at Kennedy Space Center. So that's sort of an added piece of excitement to this launch.
Very cool. Well, Dan, we appreciate your time, and best of luck to everyone. We're looking forward to seeing this in operation.
All right. Thank you so much for having me.
We'll learn more about space weather observation using this new GOES satellite when the Carolina Weather Group returns in just 30 seconds.
Have you ever seen what an indoor environmental assessment looks like in a commercial building or business? During a full assessment, we collect data throughout the building and compare the measurements room to room. We can also collect samples that go to a lab, such as the small cassette shown here, which will be analyzed for types and amounts of mold in the air. We follow up with a physical inspection, looking for moisture sources and using moisture meters to determine if any of your building materials are wet.
Go-esg.com or 336-373-1538. It's Countdown to Launch here on the Carolina Weather Group. I'm James Brierton. We continue our conversation about GOES-U, the new weather satellite set to launch and observe weather along the Atlantic seaboard. We welcome in now Dr. Jim Spann. He is a senior scientist with NOAA's Space Weather Observation Office. So welcome to the Carolina Weather Group. We're so lucky to have you. We are looking forward to the launch of GOES-U here, hopefully in the next few days. So let me ask you this very first premise question to help kind of set up for our audience who maybe is, along with me, learning a little bit more about what is space weather, because GOES-U on its website says that it has instruments to improve the detection of approaching space weather hazards. What are space weather hazards?
So that's a good question. And space weather, just like we have weather here on Earth, space is not an empty void, even though that's kind of what generally people think. There are charged particles there. There are magnetic fields. There are very intense radiation events. And so space weather is just the environment of space, almost exclusively driven by our sun, our personal star, the sun. And the sun is a regular star in the plethora of stars that we have, but nevertheless, it's an active star, and it will, I'll call it, misbehave every once in a while by it'll have a flare, which produces a lot of X-rays oftentimes, and I can talk about the impact of X-rays. It also has, oftentimes with these flares, it'll have spew out a lot of very intense or very energetic particles. And those are kind of radiation. And while X-rays travel at the speed of light and they arrive at the Earth about 8 minutes after they're emitted from the sun, the charged particles, the radiation, energetic particles, travel slower, but it's at a fraction of the speed of light. And so they may get here, hours after they're expelled from the sun. And then the third aspect of space weather that I'll share is called a coronal mass ejection. And the sun has a corona. It's kind of like the outer atmosphere, and it's comprised of plasma or electrified gas. And occasionally, a large explosion will occur on the sun, which will essentially lift off part of that corona. And so it's called a coronal mass ejection. So it ejects that mass off the corona. And if in the line of sight, it strikes our planet, it interacts with our own magnetic field and energizes particles in our magnetosphere, the area surrounding our Earth, driven by the magnetic field. And that can cause major disturbances as well. And radiation disturbances typically are, you think of radiation, chemotherapy and stuff like that, where radiation can be harmful to humans, is what I'm saying.
Sure.
And X-rays cause problems with communications. And these large coronal mass ejections are probably the biggest impact. And they can cause problems with communications, but they can also induce currents on power lines, which can play havoc with the electrical grid. And they are also the source of the aurora. So in some ways, the aurora is actually the best manifestation of space weather.
It's really great that we get a chance to talk with you here ahead of this satellite launch, but also after we had such a rare viewing of the aurora here in the Carolinas, because it gave me such a unique perspective now. I have so many more questions for you than I probably would have had before that experience. Let me just keep going on your train of thought with X-rays, if I may, because I kind of tried to self-teach myself during that aurora event here in the Carolinas about this webpage that I'm putting on the screen now for our viewers, the GOES X-ray Flux 1 minute data page, which I did not have bookmarked until we had that aurora event. So what was it that I was looking at when I was watching that spike here?
So those are two energies or wavelengths of X-rays that are shown there. A lower energy and a higher energy, and basically GOES has a sensor which is sensitive to X-rays, and it tracks it 24/7. And when a large flare occurs, you'll see those big spikes. And like I said, by the time GOES sees it, since GOES is in this geostationary orbit, the X-rays actually happened 8 minutes before, but we only detect them once they arrive at Earth, because it takes a while for light to get to our planet. And so those X-rays wreak havoc with communications. They also heat up our atmosphere, which can induce, which cause more satellite drag. And sometimes we have to be careful so satellites don't drag or slow down so much that they lose control or actually deorbit, which happened with Starlink a couple of years ago. They lost 39 satellites. Wow. So those are some of the things that X-rays can do, and space weather X-rays can do.
I think it was during that event that I first realized, okay, we have these GOES weather satellites that are up there looking down at Earth, but I guess they're also looking back out. Yep. Is that right?
Yes. So there's an EUV imager, which images the sun, and then there are these X-ray sensors that pick up X-rays. There are also energetic particle sensors, and then one that we're getting ready to launch next Tuesday has a coronagraph on it.
Is that a new tool? One of my questions for you was, there was anything on this GOES-U satellite that's new?
Yes. And so that is essentially the primary difference between the previous GOES satellites is this new compact coronagraph that was built, and basically it images the sun and images an eclipse every 30 minutes. It basically creates an artificial eclipse so that it can measure that gaseous corona around the sun without being blinded by the intense heat of the solar disk. And so it basically takes an image, just like we experienced in April, or a large part of the country as a total eclipse passed through our country, just like in 2017, one in the Carolinas, you may have witnessed it. And so this compact coronagraph images or makes an image of the sun's corona every 30 minutes and downloads that. And it's that way that it is using that instrument that we detect remotely these coronal mass ejections.
Is this tool on GOES-U that you were just talking about something that doesn't exist anywhere else on Earth or in orbit right now, that you guys will essentially be able to, for lack of a better phrase, have an eclipse every 30 minutes to collect data?
So no, there are a couple of other space-based coronagraphs. The one that is used for to provide all the space weather alerts and warnings that the NOAA's Space Weather Prediction Center issues has been up in space since the mid-1990s, and it's actually a research satellite called SOHO. It's a partnership. It's an ESA satellite with partnership with NASA, and the instrument's called LASCO. But it's been up there, and it's way past its lifetime. It has outlived, outpunted its coverage, as you might say. It is still going, but it's it's really the only one that's up there that's used operationally. And if it were to go down, we would be blind to these coronal mass ejections. And so NOAA has funded this compact coronagraph, which will go on the GOES satellite. And then a year from now, it'll launch another mission called Space Weather Follow-On, L1. And it'll be a NOAA satellite that will go out and sit about 1 million miles away from the Earth, but about 91 million or 92 million miles away from the sun, and just kind of hang right there and take images with the coronagraph and other space weather observations.
Let me ask you this about space weather in general. We know that terrestrial weather long-term has climate patterns that get associated with, changes over time. Does space weather also have, for lack of a better phrase, climate patterns that it goes through?
Yes, it does. And it's due to our personal star, the sun, has a solar cycle. It has an 11-year solar cycle. And every 11 years, the north pole of the sun and the south pole of the sun swap. And then after another 11 years, it goes back to the other way. And during that transition, the sun becomes very active, and then it becomes very quiet. And right now we're going up to the solar. It's called solar max when it's very active, and solar min when it's very minimum. When it's not as active, it's quieter. And so what that means is that the sun will have a tendency to release more flares, coronal mass ejections, radiation events, and during minimum, there are fewer of those. But that's not to say that some of the most impactful events always occur at solar max. The tendency, from what we can tell, generally occurs on the declining phase, or from solar max to solar min. We're trying to understand that a little bit better. But these big events can occur almost at any time.
Sure.
They're just more frequent during solar maximum. So solar maximum is probably going to occur in next year in 2025, or at the end of this year. And the May storms that we just witnessed is evidence that the sun is waking up.
You are going to be at Kennedy Space Center, I
Yes.
believe, for the launch. What is that like? Where do all of you get together to watch a launch, and what is that? Can you describe that sensation for us?
Okay, so there are several places to watch the launch. There are some causeways that you can just park alongside the road, and off in the distance you can see. There is a place called Banana Creek, which is a little closer, and NASA has built these grandstands, and has a big old countdown clock, and of course you can see the rocket right there and witness that. And then another place is there's an observing deck on one of the large buildings a little closer to the launch site. None of it's very close. You can't get very close to the launch site.
Sure.
Just put
For
it that
safety.
way. So,
Yeah.
you're looking off in a distance. And so those are kind of the primary areas. And yes, you see it light up and then you hear it, because light travels so much faster than sound. And hearing is probably not the right word. You feel it because,
Sure.
Those thrusters and motors are just are very, very powerful. And so, and it is just an experience that is unbelievable. It is so incredibly bright, with all the exhaust at the coming out. And, if it's overcast, you'll see it kind of go through the clouds or light up. Or if it's at nighttime, it's got that other, amazing look to it. And of course, all the smoke and everything that's coming out right next to it. It's just, it's really quite an event. And if you have spent, 7 years preparing a little instrument or some component on that, and to watch it lift off basically on top of this ginormous bottle rocket, if you want to think of it that way, it's like, oh my goodness, I hope it survived. I mean, it does, because it is so well engineered, and the people who work on this are amazing. But that's just the extra added dimension of excitement, anxiety, nervousness, and immense relief, and an exalting, proud moment to see something go up like that into space.
Well, we are looking forward to seeing it. Dr. Jim Spann, Office of Space Weather Observation, Senior Scientist there. Thank you for your time tonight, and goes you.
Thank you very much, James.
Our thanks again to Dr. Jim Spann and Dr. Dan Lindsay for joining us here on Countdown to Launch, a special edition of the Carolina Weather Group. I'm James Brierton in Charlotte. I invite you to subscribe to the Carolina Weather Group YouTube channel so you can see the launch of Goes You when it blasts off from Kennedy Space Center in Florida. Until then, I'm James Brierton. Stay safe, stay subscribed, and we'll see you again real soon. Well, it's a weather podcast. It was the first thing I thought of when I saw your name. I'll just join the long list of people who've already asked you.
I've never met him, and someday I'd really like.
I could try to make that happen, at least via Zoom if you want. I know a guy.
Oh, well. That would be kind of funny. James Spann, the meteorologist, James Spann, the space weather guy.
Space weather guy. That would be very, very funny.